Today, let's try to solve some Upwork job. Understand how to approach a problem and build a logic for it. Problem 1. Custom text-to-speech AI model developer. So, they are looking for the developer, but let's see how to do text-to-speech. So, first step is always find a similar model that can do the work. Always build a prototype before fine-tuning the model for your use case. Now, the best place for model is Hugging Face. In the model section, since we need a text-to-speech model, so let's search for TTS, which stands for text-to-speech. These are all the models that suits our use cases. Generally, what I do is find the model which is small rather than the heavy model. In this case, the top models are Parler TTS, Microsoft TTS, Tortoise TTS, and Facebook TTS. Also, there are other models that you can check out. So, if we look for the Parler TTS, in the file size version, it is around 2 GB in size. The model like Speech 5 TTS is 585 MB in size, and Facebook MMS TTS is 145 MB. So, let's go for Facebook MMS TTS ENG. Since I don't have a GPU, so let's try with Google Colab as of now. To use the model card contains all the information about how to use the model. So let's copy it in the Colab and try running it. As this is very small model, so we might not need a GPU at the moment. Otherwise, you need to change your runtime to T4 GPU in the Colab. In the meantime, the model gets downloaded. Let's explore other TTS model in Hugging Face. The same model as MMS TTS ENG, there is MMS TTS, which includes the text-to-speech model for different languages. So, this can be used if you need a model to convert your text to speech in a language that is other than English. Some other models like Tortoise TTS is also good. You can search its GitHub repo named Tortoise TTS and know more about it. Now this model supports multilingual and can also be fine-tuned to clone our voice. I have tested it a couple of times and it is really good. Also, if you don't want to directly drive into Colab for testing, what you can do is use Hugging Face space to test the model. For every model, there is a space that can be used for testing. So this model named Parler TTS can generate audio according to description, which is really cool. So you can test this for other description and use to your use case.
"This is the best time of my life, Bardley," she said happily.
Remember, this is only the first iteration of the model. To improve the prosody and naturalness of the speech further, we're scaling up the amount of training data by a factor of 5 times.
Now let's go back to the Colab. Not every time the model card has correct instruction. So we have the strange error that we need to take care to save our generated audio from the model. Now search for the problem and try to solve it. Now, after looking for a couple of minutes in the error, this was a problem of the environment of the Colab. So it can be solved if you just transpose the output from the model. Now you can or you might not face this problem while testing on your one laptop. So now we can save the audio and let's test this out.
Some example text in the English language.
Okay, it ran as expected. Now for the part 2, let's see the image generation with Openai. This script that can automatically generate the image of Elon Musk holding a camera in front of the car. This problem is a classical example of text to image. As OpenAI DALL-E is paid for premium user only, so let's do it with a free version of text to image model, which is Stable Diffusion. So as earlier, search for the Stable Diffusion on Hugging Face. Now there are various diffusion model by Stability AI, Runway ML. Now in this case, let's use Runway Stable Diffusion model, now which is around 4.27 GB in size. Now read the model card and follow the instruction. Now you can just copy the code and try running it in Colab like we have done earlier. In this case, you need GPU. So let's change your runtime to T4 GPU. The prompt that we need to use is Elon Musk holding a camera in front of car, just as the description that we have seen in the job posted in Upwork. As downloading the model will take some time, so let's see how to do it with OpenAI. Now, in the user guide of an OpenAI, you can just see after clicking the image generation, you can see how to do the image generation using OpenAI. This guide is more like image to image translation, which is also good. If you have a reference image of a person holding a camera in front of the car, then we can do this with a prompt as Elon Musk holding a camera in front of the car. Then the image will be much more similar to that of Elon Musk, and will have more control over the generation output from our model. Also, with a direct prompt, we can use OpenAI as openai.image.create. We'll pass the parameter as prompt and size, where the prompt should be Elon Musk holding a camera in front of the car, and the size is the generated image size, which you can use 256 in 256, or you can choose any size you want according to the cost that the image will require or your client will require. So you can do this using OpenAI in this way. Now let's go back to the Colab and check our result. The result is quite good but not satisfactory, as we can see that the Elon Musk is not holding a camera, is just in front of the car. So we need to change the prompt or other setting of Stable Diffusion and try again, or you can just use other model like ControlNet, which is also quite good for the tasks like this, or models from Stability AI can be also used for the tasks something like this. Now let's check some spaces for Stable Diffusion in the Hugging Face. Now in the Stability AI card, we can see that there are the multiple space. You can click any of it and use it for your use cases or test it according to your need. Now for now, let's try it with Google XD which is also quite good and quite popular. So if you just provide as a prompt as Elon Musk holding a camera in front of the car, then result seems better than our past model. Now you can either use this model or you can just use the model earlier by changing some prompt and setting for the Stable Diffusion. Now part 3. The AI photo generator to create a new photo from existing selfie. Now this problem set is similar to our earlier project. So in this case, you need to use the image to image generation technique that we have discussed for DALL-E earlier. Also, we can use ControlNet and masking for this. But if you want to fine tune this, what you can use is Dreamboat. You can find the detailed instruction on how to fine tune this model with your custom images in the Hugging Face. I will link this in the description below, and also you can just check Abhishek Thakur where you have explained the step to do this using auto train. And so as you cannot do this on the Colab because the model size is very big, but you can just modify the script to use the LoRa and use it to train in the Colab. And so that's all. Now in this case you need to just pass 4 to 5 photos of your, and the result after that will be very similar to that of your image that you have provided. Now for the part 4, the need is AI developer for the voice chat using Openai. So in the beginning we have done is text to speech, but in this case we need to do is speech to text as well. So the Openai uses Whisper model as a speech to text translation, and which is free as of now. And so for the workflow for the voice chatbot will be, now user speech should be converted to our text, and we will pass this text to GPT or any text generation model to generate a response for it. And finally we can just convert this text using the TTS model that we have seen earlier back to the voice and just give it to the user. And in this case the user speech to text should be in the real time. You can just use the distilled version of the Whisper, which is really quite fast and can be used or can be done in the real time if you just use GPU for this. The part 4, the AI chatbot code with OpenAI or Gemini assistant. Now this is a project that we have done earlier in my video. You can further watch it to build the application where we have built an API with a Swagger, which is most like similar to the first API, and documentation is already done and full source code is in my GitHub account. And the full source code includes the database connection where we have used MongoDB, and that can store the history according to the particular user, where we have just maintained the multiple user for this video. So if you have any query or if you want to develop something like this, you can just comment it out and I will try to make the video.